Hey everybody, welcome to today's online STEM session. My name is Audrey and today I will be teaching you how to get your very own superpowers. That is right, by the end of today's episode, not only will you be able to walk on a liquid, you will also be able to see sound. Now, the secret to all of our superpowers lies in the super cool properties of a special class of substances called non-Newtonian fluids, which is just a really fancy term for substances that change how liquidy they are depending on how much force you apply to them. Let's start with silly putty. Silly putty is a non-Newtonian fluid. If I apply a low amount of force like this, it just stretches, acts almost like a liquid in the way that it's fluid. But if I apply a lot of force and pull really hard, really fast, it snaps. It behaves like a solid would. Now, there's lots of examples of non-Newtonian fluids in your daily life, from paint to ketchup to your own blood. And as you might have guessed, this cornstarch solution here is also a non-Newtonian fluid. It is most famously known as Oobleck, and we're going to be comparing it to a normal, plain bowl of water, which is a Newtonian fluid. It acts the same no matter how much force we apply to it. Here's a low amount of force, acting like a liquid. Here's a high amount of force. Yeah, definitely still a liquid. But our cornstarch solution here is different. It's a non-Newtonian fluid, and it will act differently depending on how much force we apply. So here's a low amount of force. You can see that's pretty liquidy. It's not perfect because, well, it's not a liquid, but it acts like one. Here's a high amount of force though. You can see it really doesn't splatter much, and the spoon's not entering it at all. It's acting like a solid. In fact, it acts so much like a solid when you apply more force, I can even hit it. And it still acts like a solid. Now, what do you think would happen if we applied even more force than that? Even more than me hitting it? I want you to make your hypothesis, your educated guess, while I go and get a special tool of mine. All right, I hope you got it, and I hope your hypothesis can stand up to a mini sledgehammer. Let's see what happens. Still a solid. In fact, it acted even more solid than when I hit it. That's because as the amount of force we apply goes up, so does how much it acts like a solid. Now, that means in theory, we should be able to run or walk on this substance, giving us our superpower, if us running on it applies enough force. Okay, everybody, let's try it out. Here we go, testing our superpowers. And it is, in fact, working. That's because every time my feet hit the cornstarch solution, I'm applying enough force to turn it into a solid. But if I apply less force by just standing here, I quickly sink. That's actually how quicksand works. That's why you should always move slowly when trying to get out of quicksand. If I apply just a little bit of force, I can get out. But if I try to move quickly, I actually can't. It's actually so difficult. So, now that we've gotten superpower number 1 down, we need to bring in a little bit of special equipment to learn how to see sound for superpower number 2. Okay, this here is a pretty big speaker, and for our second superpower of seeing sound, it's important for us to know how a speaker acts when different pitches are played. Now, I'm going to use a tone generator to do this, and I'm also going to drop these little balls in here, and I want you to watch what happens to these balls as I play different pitches. So here's a higher pitch. As you can see, they're just barely moving, they're just barely vibrating. But if we go to a lower pitch, they vibrate a lot more. That's what's making those little balls bounce around. But if we go to an even lower pitch, you can see how much they're bouncing. That's because a speaker vibrates a ton more for lower frequencies and lower pitches than it does for high ones. So what do you think will happen if we add our cornstarch solution, or our Oobleck, to the speaker? Make your hypothesis now. So now we've added our Oobleck on top of the speaker. And since we know that lower pitches move the speaker the most, we're going to start with that. Let's see what happens. So our Oobleck was just dancing and moving in a really crazy way compared to what we would see a normal fluid do. Now that's because the speaker cone is moving a lot, and so it's applying a lot of force to our Oobleck and making it move in a really strange but really cool fashion. So those are our two superpowers for today. Because we are able to correlate different pitches with how the Oobleck moves, we are basically seeing sound. So now you can both see sound and walk on a liquid, all thanks to the cool properties of non-Newtonian fluids. If you want to repeat any of these experiments at home under parent supervision, there are instructions on how to do so in the description below this video. I hope you guys enjoyed. Special shout out to my Harmony K-2 kiddos, and we'll see you next time.